thanks very much for being here. And so just to start out, I want everyone to take a second and look around you at how much of the world around you is designed and engineered.
All?
Yes, basically all of it. You know, the chairs that you're sitting in, they didn't just happen. Somebody designed those. Somebody engineered those. The laptop in front of you or your phone, the clothes that you're wearing, all this stuff, right, even the food that you're eating. But all this stuff was designed by somebody, was engineered by somebody like you in this room. Even the software people, the software that runs the HVAC of this building was designed, okay? And so if we care about sustainability, if we want to prevent climate change from causing more droughts in California, if we want to clean up pollution so that you can eat fish out of the bay again, stuff like that, we are the people, we the designers and engineers of the world, we are the people who are in the best position to fix those things because we're the ones who make the world. And so my research here is to try to find out how we can do a better job of designing for sustainability, what drives sustainability and innovation and other value in different green design practices. And so more specifically, the goal and scope here is that when most people create green design methods, they look around in the world and they say, there's not enough sustainability going on, so I'm going to have an idea of how we can design things better. And then they just go ahead and make that a design practice. Hey, everybody should do this thing that I came up with. And, maybe it causes more sustainability, and maybe, if we're lucky, it causes some innovation. But do we know? Nobody ever tests this stuff or measures this stuff. So my purpose in the dissertation is to basically treat those design methods like prototypes that we are user testing and doing the human-centered design process thing so that we can possibly hypothesize new and better ways to do green design and come up with better design practices. And then specifically, the way that I'm doing this user feedback is I did a bunch of interviews with professionals, designers and engineers and managers and even some academics, but mostly in industry. And then I did some theoretical analysis of a whole bunch of different green design methods and certifications and green design guides, whatever people use for green design practice. And then finally, I did a bunch of workshops. Actually, I did 29 different workshops for over 600 different people. And then from 30 different companies and a bunch of students here at UC Berkeley. In fact, actually, has anyone here taken any of my workshops as a student? Yes, you definitely have. All right, yeah, cool. And then I surveyed those people to ask them, what did they value? What did they not value? What do they think drives sustainability? What did they think drives innovation? And so that's basically the outline of the talk. I'm going to talk a little bit about the interviews, then a bunch about the theoretical stuff, and then finally about the workshop survey results. So for the interviews, I asked people who are professionals and do green design what they actually do and what they value. And I also asked them about how they measure innovation, and what they think is helpful for that, what they think is helpful for sustainability. And the interesting thing that I found is that people don't do green design the way that you think they do. When we create green design methods, or even ordinary design methods, like human-centered design, the Stanford IDEO method or things like that, people teach it as if it's this tunnel of process, where you do step 1 and then step 2, step 3, and then you get spat out at the end with some green design, right? But what I found is that's not actually how the world works. Real people treat design methods as toolboxes, where, some of these tools will go together, and maybe you'll use them in order most of the time, but not all the time, and sometimes you just won't use any of this stuff, or you'll pull some other tools from some different green design practice, and it's very opportunistic. So, and I got what people liked and didn't like about various practices, but mostly what people really do is they don't use the whole method as taught. They use these different components, which are, some of them are activities, things that you physically do with Post-it notes or drawing stuff or writing stuff, and some of it is just things that you think about, use recycled materials. That is something that you can think about while you're doing an ordinary design activity like a brainstorm or a 6 hats ideation method or things like that. And there are different categories of these things. Like some design activities are for ideation, coming up with lots of ideas. Some of them are for analysis. Some of them are for research, like if you're human-centered design, if you're going out and user testing your prototypes, that's research, or if you're interviewing people to need find, that's research. There are things where you're trying to set goals, and then there's different kinds of mindsets as well. Some things give you predetermined goals, like use recycled material. That's telling you what to do environmentally. Or some things tell you what to do for social sustainability. Use fair trade or pay people viable living wage, things like that. And there are different mindsets for setting priorities or finding your own goals. There's a bunch of different kinds of these things. And then finally, for measuring innovation, this actually turned out to be kind of a dead end, because exactly 0 of the people that I interviewed had a way of formally measuring innovation in their design practice. None of the designers, none of the engineers, none of the managers really had a formal way to quantify innovation. And even the people that had vague senses of what they valued innovation-wise often didn't agree with each other. And then some people were actively hostile to the idea of measuring it. One designer said, "Do you think Steve Jobs would use any of these? He would run away from these things." So that designer is saying that measuring innovation just kind of kills creativity. Or this manager here said, if it gets the attention and support of the CEO, it becomes a thing without numbers or evaluating. We just take it on faith. And so, he's not opposed to the idea, he just thinks it's a waste of time. And then with this plus the 4 months of time that I personally spent trying to quantify innovation in workshop results and finding it to be horribly subjective and mushy and just kind of a quagmire of subjectivity, I just totally dropped that part of the research project. And then basically I measured innovation just by, in the surveys, asking people what they thought drove innovation and what they thought drove sustainability. Okay, so that was pretty much it for the interviews. I'll bring up 1 or 2 more things later, but that's basically it. So then for the theoretical analysis, I took a bunch of green design methods and practices and I broke them out into what their component activities and mindsets are and tried to categorize them, like maybe this is an analysis activity and this is an ideation activity, and how do they relate to each other. And I did this for 14 different design practices, most of which I got from the interviews, because I wanted to ask professionals what they value, what they actually use, so that I could look at methods that are really used in the real world and that people recommend. And I'm not going to go into detail on all of those, but I'm going to take you through 3 of these green design methods in detail, just so you'll know what I'm talking about later. And then these are the same 3 that I used in the workshop, so this will also set you up for hearing about the workshop results as well. Okay, so the first green design method is the natural step. It's the oldest of all the methods. It was invented in the late 80s by Carl Heinrich Weber from Sweden. And it started as a green business method, but has been adopted by a bunch of designers. And basically the way that it works is it's kind of a 4-step process that together is called backcasting, which is kind of the opposite of forecasting, where instead of starting out where you are and then projecting forward into the future, which is forecasting, backcasting, instead you start with a perfect vision of where you want to get in the future, and then you go back to where you are today and see what the gap is between them, and then have a bunch of ideas, and then choose how you'll get there. So the first step is the awareness or vision step, and that's where you're creating this perfect vision of a sustainable future for your product. And the natural step has this very particular way that it defines perfect sustainability. And it does that through these 4 system conditions. And so just to give you an example of one of these, the first system condition is, in a sustainable society, nature is not subject to systematically increasing concentrations of substances extracted from the Earth's crust. It's pretty abstract. These are summaries here, and so yeah, it's kind of complicated. And it was one of the things people didn't like about the method, but I'll talk about that later in the workshops. But anyway, 3 of these are environmentally related, and the last one is social justice related, and that's its perfect vision of sustainability. So that's the first activity. And then the second activity is doing a baseline analysis between where you are today and that perfect vision of the future. And then the third step is basically a brainstorm. It's an ideation phase where you're coming up with creative solutions, and so you just have lots of ideas. And then the final step is the decide stage, where you say, okay, we've got all these ideas, which ones do we actually want to implement to get towards our goal? And there's this mindset that it has called the 3 prioritizing questions that helps you decide which of these you want to go for. So this is it wrapped up in a nutshell here. Like I said, there's these 4 activities. The awareness activity is for goal setting, so G is for goal setting, and C is for cookie. No. C is for communication, because you can use this as something to communicate to, let's say, your client or your boss or your employees, to get everyone on the same page. And then baseline, like I said, that's an analysis step, and the creative solutions is an ideation step. So these are all the different kinds of activities that you can have. The decide is obviously a decide step. But there isn't a research step in here. There's no place where you're like going and talking to users and gathering data. And there's no build step. There's no place where you're prototyping anything. But we do have everything else. And then in terms of mindsets, there's that backcasting, that overall thing of doing this process to set your own goals. And you could argue that this could be kind of an activity as well, because it's the sum of all of these. It's not super important what's an activity and what's a mindset, it can be a useful distinction. And there are other things, the natural step funnel. I didn't really mention this, but it's the general concept that resources are becoming more and more constrained over time. So it's a predetermined goal of designing for environmental constraints, for resource constraints. And so the E here is environmental goal, and A is abstract, because that's a pretty vague concept. And then 4 system conditions, they're predetermined goals also, and like I said, 3 of them are environmental, 1 of them is social, and they're all pretty abstract. And then the 3 prioritizing questions are ways of setting priorities. And these, I didn't teach this part just due to time limitations in the workshops, but there's another thing that can help with systems thinking and setting your own goals.
One question.
Yeah.
Where does the reality check come into this whole scheme? Suppose I want to do something about airlines. I want to reduce power. my obvious creative idea is we're making a gravity shield. So, at what point, is kind of, such nonsense we leave out?
Yeah, that's in the decide step.
Okay.
Yeah. And yeah, because one of the prioritizing questions is about return on investment, what's affordable or practical or possible. Yeah. Okay, so that was it for the natural step. The second method here is whole system mapping. And just full disclosure, this is a design method that I created in 2010, but it was independently mentioned by people that I interviewed, and I also think that it doesn't compromise my objectivity because, like I said, this is not a horse race between different methods. This is user testing to make all of these methods better. So I actually want to find out what's wrong with this method. Like maybe I can steal some things from the natural step to make this better, or vice versa. And the first step of whole system mapping is drawing a system map of your whole product. And this includes the bill of materials, like you can see LEDs and batteries and stuff. And it also includes the full life cycle of the product, so the raw material extraction, the manufacturing, assembly, packaging, transportation, end of life, landfill down here. And it includes the use phase, so you can see electricity use during its life, and what the user actually uses it for, and what they do with it. And then and so this is a way of analyzing what the whole system is, and getting it all out there. And then you do what's called life cycle assessment of this, which is a way of quantifying the environmental impacts of things. And that helps you set your goals for green redesign. So the LCA, the life cycle assessment, will tell you maybe electricity use is the biggest environmental impact, and so that's the goal that you should try to fix in your design. And you can put in other business goals here, like don't raise the cost, etc. And then the next step is you brainstorm on this system map, and it's just a little different from a normal brainstorm because you're using the system map to brainstorm on. And there are two mindsets that go along with this. One is that you should try to have at least one idea for everything, just to make a more thorough brainstorm. And that you should try to eliminate nodes in the system here, eliminate steps or eliminate components, because that can give you a more radical brainstorm, can get you more creative ideas. And then this one also ends with the decision-making step, where you try to estimate the environmental improvement of your favorite designs, and then balance that against your other business considerations like cost and performance. So in a nutshell, the draw whole system map, that's an analysis activity and can be a communication tool. LCA is analysis. Prioritized design spec, that's you setting goals. And brainstorming on system maps, ideation. More analysis for estimating the improvements of the final ideas and decision making. And then with systems thinking, obviously that is a systems thinking mindset. There are lots of green design methods to try to drive system thinking, so that's a whole category. And then predetermined environmental goals that are very concrete because you've quantified the environmental impacts, setting priorities, and et cetera, et cetera. Okay, so that was it for whole systems mapping. And then the third one that I actually did workshops on is biomimicry. And again, full disclosure, this is sort of my version of teaching biomimicry. There are a bunch of different versions out there. So I've worked with the Biomimicry Institute on and off 14 years or so. And they have come up with at least 2 or 3 different versions over the years. And like Bob Full here in the mechanical engineering department, he has his own different method for teaching biomimicry. And so this is my version of it as well. And first step here is to redefine the problem that you're trying to solve in terms of biology. So how do plants and animals waterproof themselves? Or how do organisms create lightweight but strong structures or things like that? Think about it as if you were an organism trying to survive. And then the second step is to look to nature for inspiration. Actually, that's a general mindset of the whole thing, is using nature as mentor, looking to nature for inspiration. And this specific activity is finding models in life, so actual physical object, a horn or a foxtail, and trying to analyze what's going on engineering-wise. Why is this structured the way it is? Why is it that color? And what does that mean design-wise? And then you can have your various ideas about how that might improve your design. And then the other way to find ideas, and these are both research activities, basically. So asknature.org is a website that's kind of the Google of biomimicry. You can just do a search for waterproof or structural strength or something like that, and it'll come up with a bunch of organisms and their different strategies that they use to do it. And again, full disclosure, I designed the first version of Ask Nature 14 years ago, but I don't think that compromises my objectivity, again, because first of all, that was 14 years ago, and this is like version 4 now, so this is totally different from what I designed. And again, I'm trying to find out what people like and don't like about all these things. And there are other parts of this method that I created as well. Like the next activity is another one that I put together, which is translate to a buildable thing. The previous step, these people had some ideas. This one is based on a polar bear. This one is based on a bat. I guess you can't really see the drawings, but this one, you can see the butterfly. And that's all very well and good, but when we're, making a laptop or a table or something, we have certain manufacturing restrictions and material constraints and stuff. So how do we build our version of whatever this cool idea was? And then I also contributed some, or have my own version of the final step, which is looking at principles of how nature works. And so this one is put together by the Biomimicry Institute. I also augment it with some other ones from other sources. And this acts as predetermined goals for people, and some of them are very concrete, like do chemistry in water. That's a very concrete goal. And you can use that as a way of measuring your success of your design. How sustainable are you? Well, are you doing chemistry in water? Are you cultivating cooperative relationships, et cetera, et cetera? And so a couple of these are concrete. Most of them are more abstract, like incorporate diversity or reshuffle information. But they can be both a way of measuring your success or setting goals, and a way of brainstorming. You can say, well, let's sit down and have 10 ideas on how we could do chemistry in water.
But that last one, the fracking people do chemistry in water.
Yes.
And so you have to be very careful. I mean, is it good chemistry in water? Or using way too much water, particularly in a state where you have maybe a drought? Then maybe doing too much chemistry in water is not the way to go. So
totally.
There's always these sub-questions that you then have.
Totally, yeah. And this is not meant as a checklist where you're supposed to do all the things, but actually that point of view will come up later in workshops. So yeah, foreshadow. But just to summarize here, here are the different activities. We've got some goal setting. Here we do have research activities, which we did not have in either of the previous methods. But we don't have any decision-making activity, particularly. And so this is the summary of these methods. So what do we do with all this? Well, this is analysis that I did of 14 different green design practices. And so here's the natural steps, whole system mapping, biomimicry, and various other ones in these rows. And then the different columns here are what kinds of activities they have in them. And so like human-centered design here, not a green design method, but worth looking at because so many people use it. And a really interesting thing that I found right away is, well, first of all, it's more heavy on the research, so that's a useful distinction. But it is the only thing anywhere that has build activity. It's the only one where you actually prototype anything. And so right away, this says to me that okay, we should be combining some of these practices here, right? Because you need to get your product to market. You know, you need to build something at some point. So really, none of these green design practices are going to be enough by themselves. You should combine them with human-centered design, or at least some other kind of status quo design method. So that was one thing. And then the other big finding is that you can see there's a big difference between these green design methods, where you have a whole bunch of steps that you're supposed to follow, versus green design certifications and guides, which are more of just a checklist of things to think about while you're designing. So all of these are very heavily on the goal setting. And so they're not really telling you how to do things. They're not telling you you should analyze or research or whatever. You just do what you're going to do and think green thoughts while you're doing it. What's that?
The certification concerns greeniness.
Yeah. So these two are certification systems, and they mostly are a checklist of did you do this, did you do that. They do have a couple research activities like cradle-to-cradle certification. They want you to go and actually take data at factory manufacturing stuff to check the pollution levels in the wastewater.
So some involved in some system.
Yeah, exactly. Yeah, and they'll have you calculate the percentage of recycled material, basically. So that's an analysis activity. But yeah, but mostly they're checklists. Yeah.
In a way, I could almost take a simplistic approach and say, take whatever design method you have, but put the end result, the cost function, whatever it is, in a form where you measure all of these things, and then figure out how good it is. And, we're not really so much worried about different green designs. We want to have green outcome.
Yeah.
So then the only question maybe is, in whatever design method you use, or you're starting from whatever diagram of the 50 diagram that Alice Akagina has collected how to do design, at what point can you make a high probability influence to have a good outcome by changing the mindset, or giving sources where you look for innovative ideas, or a way to just collaborate with these others that create something that one person couldn't do. So it's more like stuffing your general design method with a few good tools out from a very special toolbox so that the outcome is good.
Yeah, and actually that is what most people do, honestly. Most people will practice human-centered design and then throw in some sustainability considerations along the way. One criticism that I've heard about that from people in industry is that designers hate it when you say no to them, and so if they've had 100 ideas that they think are really cool, and you tell them they have to throw out 99% of them because they don't fit the checklist, then they will hate you. And so that's part of why people have come up with these green design methods, where you try to start off from a sustainability point of view and ideate from there, so that it's more positive and less negative. Yeah.
I have a question as to whether you consider any of the approaches in agile project development, which is mostly used for software, but it's being contemplated or maybe used in some places that are not software now?
Yeah. And a couple people that I interviewed did mention it, but basically not enough people mentioned it for me to decide to put it on the list. But I thought about it. Yeah. And so I think there are three things that we can get from this analysis, and the analysis of the mindsets that I'll talk about in a second. First of all is finding the best tool for the job. Like if you're really happy with your design process and you just want to be able to think some more green thoughts, then you should probably hit the green design methods, green design guides or certifications. Whereas if you really want to dig deeper into like figuring out your own priorities and stuff, or doing more analysis, then you're probably better served with these. So that's one thing. And then secondly, if you want to make better green design methods by hybridizing things, you should probably combine things that are very different from each other, right? Like these two certification methods, they're pretty similar, so it might be a waste of time to try to do both of those. but maybe it would be good to combine one of these with the natural step. And then finally, different methods might be good for different people. Like engineers, they're very comfortable with analysis, so maybe they would prefer these, whereas designers, they might prefer things that are heavier on ideation or goal setting, and managers would probably be more into the goal setting, so maybe they would like some of these things. So that was a hypothesis that I put together. And again, the mindsets can help to differentiate these things as well. So, because like we were saying, the natural step, it has a lot of different considerations, and like it has social sustainability considerations, which whole system mapping and biomimicry don't. But it doesn't have any concrete things, it's all abstract. So, again, choose the right tool for the job. Do you want the general stuff, or do you want really concrete stuff? Or do you care about social stuff versus environmental? And so putting all these together, I thought about who would probably prefer what method. So I think managers would probably prefer the natural step because it's very abstract, but it is more systemic, and it's not very analysis heavy or research heavy. Whereas biomimicry would probably be more for engineers and designers because it's more research heavy and more concrete. And then whole system mapping probably about in the middle because some of it is concrete, but some of it is systems thinking, high level stuff. And we'll see how this worked out.
So this is, I guess, recommendations based on sort of your own intuition of what different people would end up enjoying or being good at?
Yeah, and based on these things, like, I'm assuming that the managerial people will probably prefer abstract things, designers and engineers prefer concrete, and stuff like that. Yeah, and analysis activities versus goal setting. Yeah. So that was a hypothesis. So how did that turn out empirically? Well, like I said, I did a bunch of workshops for different companies, and actually all those Post-it note photos before were from workshops that I did at various places.
Can you give maybe one concrete example of what it is that you try to design and then how you apply these techniques?
Yeah, absolutely.
Like was the one before seemed like a factory that they trying to design or something from just a chimney and all?
Oh, yeah, no, that was drawing out the whole system, so this was the manufacturing step.
So for instance here, what were they designing?
Yeah, this was for a TV set-top box, where you can like stream Netflix or whatever through your TV. And actually in one more slide, I have a better slide to list examples of. But first, just quick demographics. Like I said, there were about 600 participants. A little less than half were professionals in industry, a little more than half were students. Not everybody responded to the surveys. Some people flaked out, whatever. And with the professionals, some people flaked out, and then there were some other people that I didn't think were really my target audience. There were some architecture people, there were some software people. No offense, software folks, but I was looking for, for physical design of stuff. And like some marketing people. I'm not going to kick them out of my workshop, but I wasn't going to take the data either. But anyway, I ended up with 434 qualified respondents. And the results were similar between the students and professionals. Not exactly the same, but I'm just going to go through the professional results here, just for the sake of time. And other demographics, they were about 60% manufacturers of actual products, like the Gap, Steelcase, North Face. So some of the things that we were looking at were consumer electronics, like a laptop, or pieces of furniture, like a couple tables and a chair, or various yoga wear, and different things like that. And so about 60% manufacturers, 40% design or engineering consultancies. and about 60% large companies, 40% small companies. It was also 60-40 male-female participants, and in terms of the designer, engineer, manager, there's about 30% designers, 30% engineers, 20% managers, and then also ended up being like 10% sustainability specialists. And for industries, it was about 40% consumer electronics, 20% furniture, 20% apparel, and 10% other stuff. So yeah, did that answer your question?
Yeah.
Cool. Yes.
So how did you come to the pool, just to think of possible biases?
Oh, yeah.
Just because of your solicitation?
Totally fair. Yeah. So I contacted lots and lots of people. You know, I put word out on various email lists, like the Stanford Design Alumni email list, and other ones. And I recruited people that I know in the industry, and also went to a couple conferences. So a bunch of these other companies are from the Sustainable Brands Conference, and then there was at Singularity University, they had me do a workshop there for 8 of their startups, so that was about 30 or 40 people doing different kinds of products. And so I tried to get a very broad spread and avoid bias, but it was definitely largely skewed to people here in the companies here in the Bay Area. There was only one company where I did a site visit to Michigan at a steel case. Except the Sustainable Brands Conference, that was a nationwide thing, people from all over the country, and actually a lot of European and some Asian companies were there. And my interviews were more widespread. I had a bunch of people from Europe and South America, and at least 1 or 2 from Asia, 2 from Australia and New Zealand. So I tried to have as broad a spread as I could.
Yeah. So, question on the set-top box example that you had.
Yeah.
So, what were the key innovations that came in? What, if anything, did you get from Biomimicry? So just referring back to the various sources and so on, in one concrete example, what did actually happen? And where, in the end, maybe was the dominant benefit coming from?
That is what I'm going to talk about next.
Super.
Yes.
I'm just kidding.
I paid him.
Thank you so much.
Yeah, so the results for the natural step were, this was overall what people valued and didn't value in terms of the different activities and mindsets. So the clear winner of what people really valued was backcasting, far and above over everything else. And interestingly, all the actual activities kind of ended up even. And so what this says to me is that there's a situation where the whole is greater than the sum of its parts, because each one of these activities individually is nice and all, but it's really the combination of the 4 of them that people really find valuable. And then the thing that people criticized the most was for system conditions. And in fact, one of the interviews that I did, which is not this data, this is the survey data from workshops, but one of the interviews that I did, a guy said that he first tried the natural step 10 years ago, loved the backcasting, hated the 4 system conditions, so he just threw that out and uses his own sustainability mindsets to guide the process. And he's been doing it ever since and totally loves it. So I think that's a great example of how we can improve these green design methods by seeing what people like and don't like. And the thing that people liked about this was largely the strategic planning and the way you can set bold goals with the awareness and then follow up on how to do them later on. And so I think that one possible way to hybridize methods like we talked about earlier is this might be really good to hybridize with the Cradle certification or EPEAT certification or some of these green design guides that give you a list of things to think about. And what people liked in terms of sustainability and innovation was Interestingly, backcasting was not the big winner here. And I think what this tells us is that it really was some of these larger scale strategic things that people value about it. Like, in terms of sustainability, it was good and all, but within confidence intervals of anything else. And innovation-wise, again, within confidence intervals of almost anything else. So I think what people really valued it for was that strategic planning and the setting goals and focusing thought on certain parts of the system. And so things where people did find a lot of innovation was in the creative solutions, the ideation activity, so that's what you would expect, that's nice. But interestingly, they also found a lot of sustainability value in that as well, which I was really surprised by, because the whole purpose of all these other activities and mindsets is to get you thinking about sustainability, and yet people valued the brainstorming just as much for sustainability as any of the other things. And what people said in the surveys was basically they felt really productive, and they felt like they were having concrete, useful ideas for sustainability in the brainstorm stage. But they probably needed these other things to get them to that point.
Do I read this right if I think that people feel that for systems and decide by priorities really stifle innovation? They seem to have, these error bars that go into the negative domain. Right. Not that.
Right. Well, so not quite that bad. Like, nobody said that it stifled innovation. They just failed to mention it helping innovation. Yeah. Although, if people said so stifling would have happened in the negative here, but I don't think anybody said that. I think they just said it was confusing and vague. Okay, yeah. So just summary: the main thing people liked in the natural step was backcasting, and for strategic planning, setting bold goals and helping focus their thoughts. And then for whole system mapping, the things that people mostly valued was the drawing the system map, that analysis activity. And here there's more of a spread between other stuff, but basically the thing that people disliked the most was life cycle assessment, which is not terribly surprising, as some people know. But it is too bad because it's really useful for sustainability. But this suggests maybe that's a way to hybridize or improve this design method is, maybe we should cut that out and replace it with something simpler, like a set of predetermined environmental goals from one of these design certifications or design guides.
So is it just the tedium of figuring out, what the life cycle analysis would actually be? And so that's why people think it's a lot of work and doesn't tell you much. So if you had in a way better tools, where you just have an analysis tool and then your final product, it looks at all the materials and looks at the life cycle cost and gives you a number, right? And people just push that button and get the number and probably be not so averse against it.
Exactly, which is actually why one of the fun capstone projects that I'm leading is how to make better life cycle assessment software. Yeah, totally.
Or have somebody with that mindset on the team.
Right, exactly, yeah, just have someone with that expertise on the team, totally. But then LCA was very popular sustainability-wise. Actually, it scored the highest of anything in all three of the green design methods. Although, with uncertainty, with the, confidence interval bars, that's not a real result, but, sort of roughly. And then, again, the thing that people valued the most for innovation was the ideation activity. And again, it's got that thing where it was also really good for sustainability as well, which again, I found surprising, but is really interesting. And then again, drawing the whole system map, it scored well in both of these, but didn't score, amazingly well like it did here. And so again, I think this shows that a lot of what people valued about it was not just sustainability or innovation, but they liked how it broadened the scope of their analysis, looking at the whole system, and they liked how it helped focus thought in the brainstorm later on by having you look at different parts of the system. And they said that it was a good collaboration tool. It helped them to work together.
On sometimes abbreviated the same way. Are you referring to life cycle cost assessment?
No. Environmental assessment. So like
Environmental.
how many kilos of CO2 emissions and sulfur dioxide and land use.
So cost is not a factor,
No.
but it's still collecting the cost in some way, not dollars.
Yes, the environmental cost. Yeah.
Yeah, when you were having these workshops, were you going through different of these design methods for a single group, or was each single group only experiencing one design method?
Oh, right. Yeah, sorry. I forgot to mention that. So each individual workshop was just on one design method, but some companies got multiple workshops. So around 10 different companies had multiple workshops. So they'd have the biomimicry one day, and then a month later they'd have the whole system mapping one, or stuff like that. Yeah. Okay, and so just to summarize here, draw system map was the main thing that people valued. They valued it for broadening the scope, focusing thought, and collaboration. And then finally, biomimicry, the things that people liked and didn't like, they really liked the general idea of looking to nature for inspiration, nature as mentor. But it wasn't as clear a winner. They also really liked the specific activity of Ask Nature. And this was viewed by people as a really good source of new ideas and of new perspectives, new way of thinking about stuff. And people said that it was just really fun, too. One person called it Animal Facebook. So, yeah. And, but then the models in life activity was surprisingly, maybe not super surprisingly negative, because even though a lot of people find that fun, it's like, ooh, tactile, we get to play with things. But then a lot of people were like, this foxtail has nothing to do with the laptop that I'm trying to design. Why do I have this? And so that's, which is fair, right? Like that's where the negativity came from. But then what I was disappointed by was translate to buildable things, which, like I said earlier, I think that's a really important thing. People didn't value it that much. And what they did value just as much was just listing examples of biomimetic products during the lecture, which, that's not part of this. That I was not even thinking that would be a thing. But apparently people really love it because it helps to make concrete this general vague idea of let's get inspired by nature. So that was really interesting that, if you're teaching people biomimicry, you should really use examples. And in terms of sustainability and innovation, AskNature.org was the huge winner for innovation. But unlike these ideation activities in the other two methods, does not score very well for sustainability. And this gets to what you were talking about as well, of like, yes, just because the hermit crab does this thing, and that could be a cool engineering thing for my laptop, doesn't mean it's more sustainable necessarily. And so a lot of people felt like that. And I wonder if that's because this is a research activity, not an ideation activity where you are having the ideas about how to be more sustainable in your designs. And then, really nothing here scored very well sustainability-wise, which was kind of surprising, but in retrospect, very, very understandable.
So did biomimicry contribute something concrete to the set-top box that you did?
Well, that particular group only did whole system mapping. So that was, so they didn't do biomimicry.
I see. So in these workshops, it was not the focus on a kind of thing that you designed and then looked at different ways of doing it. You just focused on one method.
Like I said earlier, each workshop was just one method.
Does that make sense? That's the right truth. But I mean, no, I'm sort of shocked, I mean, if mostly my company designs laptops, right, then the focus is, give me the 6 most likely approaches to make my laptop more friendly, and then compare them, right? And in the end, I want a better laptop design method rather than learning very deeply about my Mimicry, which may not contribute anything to my laptop.
Well, and that's exactly what the purpose of my dissertation is seeing what people like and don't like about these different methods so that we can make better recommendations to
So you
people.
can have the right subset and go with those and teach those.
Right, exactly. Yeah. And so, okay, yeah, so just to summarize, what people liked here was mostly Ask Nature and Nature as Mentor, and they valued it for new ideas, new perspectives, and because it's fun, Animal Facebook. But so then results by demographics. You might remember this thing that I thought was going to happen earlier. Turns out that is not a thing, really. So this is showing you responses for the natural step of designers and engineers and managers and sustainability specialists. How many of them said it was useful for sustainability and for innovation. And same thing for whole system mapping and biomimicry. And here, it looks like there's a little bit of a difference, but error bars, not a real thing. And for whole system mapping, really everybody felt exactly the same way, basically. And really the only difference here that was at all statistically significant is engineers disliked biomimicry more for sustainability than anything else. So, not so much. And I did these kinds of demographic splits for everything. I did them for all the activities and mindsets in sustainability and innovation and for general value, all that kind of stuff. I did about 4,000 different statistical comparisons, and almost nothing was statistically significant. And so at first I was kind of like, oh, that's too bad, but then, thinking about the final conclusions of, what I would recommend to actual designers and engineers in industry, here's the revised version of that diagram. And I actually think that this is a really positive thing, because then you don't have to teach different methods to different people. Everyone can share together. And yes, individual people will like one thing better than another thing, but more likely they'll all use different bits and pieces from different methods. And actually, I think this reinforces the perspective that, a lot of us Stanford designers or IDEO designers or things like that think that design thinking is the universal tool that just works for everybody everywhere. And this kind of supports that, or at least in the 3 green design methods that I tested. Maybe not for everything, but it does kind of support that. So hypothesizing how we might improve these design methods, maybe you could take the natural step, remove the 4 system conditions, and add predetermined goals from a design guide or a certification. Or for whole system mapping, maybe you could take out the LCA and add in one of these checklist style certifications that's easier for people. And for biomimicry, maybe you could take out the models in life and add in life cycle assessment, because people thought that there wasn't enough sustainability stuff going on here, and so maybe it needs more from the LCA. But again, maybe you can just pull any of these different things. You could put all 3 of these design methods together. You could combine backcasting with, the golden tools that I found from people's toolboxes. This was really what people found the most valuable, and if you were just trying to get your laptop designed and you want to use the best stuff, you probably want to use some combination of backcasting and or drawing system map and or Nature as Mentor or Ask Nature. So those are the final recommendations.
So I almost get the feeling that it doesn't really matter so much what design process you're using. You can use this mix and match. But what we really need is better toolboxes and better ideation databases, for instance. So if I have to do structures, right, if I could go and I have a nice searchable web page that gives me structures come out of biomimicry, that come out of nanotechnology, that come out of the way plants grow and emit themselves, really steady. And so I can quickly look through that spectrum and hone in on something that may be close to what I really have to solve. And so, that's sort of to get the ideas. And then, as we said before, analyzing the recycling costs. Like if you have better tools, you can just push a button and it does some little analysis and gives you some kind of an environmental cost factor of what it takes to recycle that thing. And we have all of those plugins, right? Then the design method itself, becomes much more fluid, but you have these very powerful tools that you access through that method.
Yeah, totally. And again, that's what I was saying earlier about picking the right tool for the job.
Mm-hmm.
If more ideas is what you need, then yeah, having Ask Nature to look up ideas in, or the structural database that you're talking about, that would be the right tool for the job. Whereas if what you feel like you need is an analysis tool to help you to figure out what the problem is that you're trying to solve, then yeah, better LCA tools, et cetera, et cetera. Yeah. But yeah, so that is pretty much it for my recommendations on green design practice. And just one more little thing before we wrap up. On a personal note, as some of you know, I have a job lined up in the fall being a professor. And so I just want to say, Dartmouth.